Okay, hello and welcome to the video. My name is Wade Smith, and this video is me discussing the fact that they classify things as tropical depressions and tropical storms now, which decades ago would not even get mentioned. Um, and then they end up doing no damage to anybody, and it's just, oh my God, it's a tropical storm, look out! And it causes a panic, but nothing happens because it doesn't even have tropical characteristics, and they call it a tropical storm. Like, at least be completely rotating all the way around and have some rain wrapped around the center. The one that hit Louisiana a couple weeks ago ended up being nothing at all. It hardly even had any real rain in it, especially on the north side. Um, it shouldn't even have been called a tropical system. And I doubt that it had 40-mile-per-hour winds in it. Uh, Much less 40-mile-per-hour winds completely wrapping around the thing. But the way they classify storms now, if they find one 10-second gust, it's supposed to be a 1 minute sustained wind that they classify it by. But they in for the past couple of decades, they've been classifying them by the 10-second wind, and that's a different thing. All right, it's easier to get a 10-second wind than it is to get a 1 minute average wind. But they started classifying them about a 10-second wind, and the tens, which is cheating on the scale, by the way. And the 10-second wind is easier to obtain. So all they have to do is go out there and measure wind for 6 hours, and if they get 10 seconds worth of 40-mile-per-hour wind, they call it a tropical storm. Well, damn, every thunderstorm on the earth must be a tropical storm. Um, wow, you only need 10 seconds of wind to call it a tropical storm now. That's why other countries don't use the 1 minute average either. They use a 10-minute average or a 3 minute average because even the 1 minute average is overestimating the real intensity, the landfall intensity of what a storm is going to be. Um, I saw the damage in Jamaica, and there is no way that that was a 190-mile-per-hour 1 minute sustained storm, Melissa, that hit Jamaica, because a 190-mile-per-hour 1 minute storm would be worse than Camille or Katrina, or worse than Camille and Katrina combined. All right. And they had houses that were not even that well built that survived the eye wall of that thing. And trees weren't even blown down, trees that were left standing. If a 190-mile-per-hour hurricane actually hit an island with mountainous terrain, it would blow down every tree in the eye wall. Every tree. I've been through 110-mile-per-hour eye wall, and it blew down one out of every three trees on the property and on the neighbor's property in a heavily forested area. Blew down one out of every three trees. I'm talking about pine trees and oak trees in Louisiana. That was only a 110-mile-per-hour eye wall, the leftover remnant of Ida, when Ida hit as a 150-mile-per-hour storm down by Port Fourchon. Um, a 190-mile-per-hour 1 minute sustained hurricane with a supposed gust of 252 miles per hour, supposed 10-second gust of 252 miles per hour, should have blown down every tree and every house and even every high-rise building in its path if it was actually as strong as they rated it to be. Because that's what that kind of wind does. That's what that's in well into the EF5 range of tornado wind speeds, because tornado winds are rated by the 3 second wind, the maximum 3 second wind, based on an estimate, based on what happens in wind tunnels, and based on an estimate of the breaking point, the failure point of materials. Tornadoes are estimated by the EF system, Enhanced Fujita system, to be 3 second wind, and an EF5 starts at 201 miles per hour of 3 seconds of wind. So if that thing had gusts to 252 miles per hour, 10-second winds, if you just go look and see what a real EF5 tornado does in Oklahoma or Texas or Nebraska, where they hit more often than other places, and look up the videos and see how catastrophic the damage is. It wipes everything down to the concrete foundation and rips the pylons out of the basement and throws it airborne, and can pick a pickup truck up and throw it 40 miles through the air, is what an EF5 tornado can do. And this thing had winds 52 miles per hour stronger than the minimum EF5 rating on 10-second scale, supposedly. So when you look at the damage that happened in Jamaica, it didn't do that much damage. So either their radar is wrong, or the SFMR instrument, that microwave instrument that studies the ocean sea surface, is wrong, or they're both wrong, or the dropsondes are wrong, or they're all wrong. But there is no way that you can tell me that a house that had a single sheet of plywood on it was that and 4-foot centered studs survived a 190-mile-an-hour hurricane. When they hit in Louisiana, we have much higher building codes than them, and when they hit in Louisiana, 140 to 150 mile an hour hurricane will blow the house plumb off the foundation. It'll even blow a brick house plumb off the foundation. So they did something wrong on Melissa. I don't know what, but to say, but that couldn't have been 190 mile per hour sustained landfall. Couldn't have been 185 mile an hour sustained landfall either. When the Labor Day hurricane hit, it derailed an old school locomotive, and that was the wind damage. And it supposedly polished the palm trees with sandblasting them and ripped people's faces and hands off. And it was supposedly rated the same thing as Melissa. But you didn't hear reports like that in Melissa, because Melissa was not as strong as the Labor Day 1935 hurricane. It ripped the skin off of people's faces and hands and polished the stumps of the palm trees. The wind ripped the bark off the palm trees and sandblasted the palm trees during the Labor Day 1935 hurricane. So they had to have done something wrong on Melissa. It couldn't have been that freaking powerful, or it would have done twice as much or 10 times as much damage as what you actually saw on the ground truth. The other thing is that when a dropsonde does not measure the 10-meter winds, a dropsonde measures wind for 10 seconds of free fall. So it's measuring an average of the winds from a couple hundred meters up down to the surface during that last 10 seconds of free fall. And that's going to overestimate the winds by a significant amount. All right. Because in 10 seconds of free fall, even with a parachute, a dropsonde is going to fall a very long distance. So it's not measuring the real surface winds. It's measuring something a couple of thousand feet up and calling that surface winds. All right, but let me get back to the topic here. They're overrating all of the storms because they don't do any. Helene was overrated. The anemometers on land never even recorded Category 2 force winds out of Helene, and they call it a Category 4 landfall. That's not a Category 4 landfall. A Category 4 landfall will blow your house off the foundation, even a really good house, if you're within 5 miles of the coast. That's 130 sustained with gusts to 170 is Category 4, the low end of Category 4, which is what Helene supposedly was at landfall. And yet the real anemometers on the land never even recorded Category 2 sustained winds. So if they're going to overrate storms by that drastically, because they overrated it by at least 30 miles per hour sustained and maybe even more like 40 miles per hour sustained, if they're going to overrate storms that drastically, they need a new system of measurement and a new system of classifying storms so that they're not overrated. And what made Helene do the flood damage was not the hurricane itself. It merged with a cutoff low upper level trough that came in over Tennessee, and that absolutely flooded out the Carolinas. It wasn't the hurricane itself that did the damage. It was the hybrid low that formed when it merged with the upper level cutoff low. is what did so much flood damage. And also the fact that it was moving so slowly as as the situation evolved. And yes, even amateurs correctly forecasted that situation. That was a very obvious scenario. My great aunt asked after a couple weeks after that happened, asked me, "Did the scientists know that was going to happen, or did they, or what?" And I said, "They knew that was going to happen. That's actually an easy forecast." I said, "That's actually one of the easier forecasts." I knew it was going to happen. The amateurs knew it was going to happen, and the pros knew it was going to happen. The one they got wrong was Otis. They absolutely demolished and blew the forecast on Otis, and I don't know why, but never tell somebody never. Never say never in forecasting, even if you think you got it nailed down. Never say never. But as soon as you say it'll never go there, it's going to go straight there, buddy. I can promise you. It'll never make a right hand turn. It'll never be a category 5. We think it's just going to be a tropical storm and turn left, and it turned right and hit as a category 5. That was the worst forecast in the history of the National Hurricane Center. All right. And that one they actually know was a real category 5 based on the anemometer measuring a 205-mile-per-hour gust. That it takes about a 260-mile-per-hour storm to get a 205-mile-an-hour gust. All right. So, um, and what did it do? It was only supposedly 160 mile per hour sustained, and it blew the facades and it caved in high rise buildings. This is why Melissa is not a 190-mile-per-hour hurricane. The 160-mile-per-hour hurricane caved in high rise buildings. It blew the floors out and gutted the buildings from top to bottom. All right. If Melissa had been 190 miles per hour, it should have toppled anything it hit. So again, they're still doing something wrong on this rating system. My point is that they're exaggerating all of them now because they have satellite technology and they're looking at the upper level winds, and the upper level winds are going to be 15, 20, 25% faster than the surface winds. The reason they call a severe thunderstorm severe and they rate thunderstorms by 3-second winds, that's 50 knots or 58 miles per hour is considered a severe thunderstorm officially, although they usually round it to 60 miles per hour. Or 1-inch hail is because 60 mile per hour, 3-second wind will usually blow trees down if it's really 60 mile per hour, 3-second wind. It's usually going to blow trees down at 60 miles per hour. And I can't do the math in my head because it's too complicated. But statistically, they do know that this formula works. Wind damage is proportional over the long term in hurricanes. Wind damage is proportional to the 8th power of wind speed. All right. So if you had a hurricane that was supposedly 190 miles per hour, it is actually going to be 10,112 times as damaging as a 60 mile per hour, 3-second wind. That did not happen in Jamaica. If it had, the whole country would have been wiped out. All right, I think I've done enough. They're overrating all of the storms in modern times. There is no way that they they're getting to 190 miles per hour sustained when they don't even know how to measure sustained winds. The dropsonde does not measure sustained winds. It measures 10-second wind across a multi-thousand meter column of air.